Welcome to the session evaluating the impacts of city logistics policy measures. My name is H. Taniguchi. In this session, I would like to highlight how we can evaluate the impacts of city logistics measures, focusing on the efficiency of logistics as well as environmental friendliness. Let's take a look at city logistics policy measures, which have been proposed and implemented in a number of cities throughout the world. First, we have definition of city logistics. City logistics is the process for totally optimizing the logistics and transport activities by private companies with the support of advanced information systems in urban areas, considering the traffic environment, its congestion, safety, and energy savings within the framework of a market economy. City logistics aims at totally optimizing urban freight transport, balancing the economic growth and the environmental friendliness, safety, and energy savings. We can utilize advanced information systems with ICT, information and communication technology, ITS, intelligent transport systems, and IoT, Internet of Things. City logistics initiatives are performed on the market economy, as too much regulation is not preferable. We have visions for city logistics. There are three pillars representing goals, namely mobility, sustainability, and livability. Mobility is associated with the seamless and reliable goods movement in urban air freight transport. Sustainability is essential for improving the environment. Livability is related to safer and healthier communities. Recently, resilience was taken as another important goal, ensuring the humanitarian aid logistics in disasters. We have a number of cross beams of evaluation criteria, such as global competitiveness, efficiency, environmental friendliness, safety, security, and others. Therefore, city logistics is a complicated system with multiple objectives and multiple criteria. We have three categories of city logistics policy measures: infrastructure, regulatory, and economic ones. Let us look into the insight of these policy measures. The first one is infrastructure policy measures. We have transport infrastructure and information infrastructure, and both are important for modern logistics. Ring roads and access roads to seaports and airports allow traffic congestion to be alleviated, resulting in the smooth distribution of goods to customers in urban areas. Appropriate layout of loading-unloading bay for pickup delivery trucks on streets ensures better delivery systems in busy central districts of cities. Information infrastructure plays important roles for providing smart logistics systems. Digital roadmap and GPS are basic tools for collecting operation data of trucks and planning urban freight transport. Truck load matching system is able to reduce empty truck movement by matching the vacant truck space and demands for carrying goods via internet. Here you can see examples of ring road planning in metropolitan Tokyo area, Japan. Ring roads surrounding large cities are effective to reduce unnecessary through traffic by trucks entering city center and promote effective use of road networks. The improvement of access roads to Port of Oslo, Norway is another good practice for allowing freight vehicles to easily access to logistics facilities nearby the seaport. You can find use of ITS for road freight transport management in Japan. ETC2.0, Electric Toll Collection version 2.0, can collect precise data of truck movement by communication between onboard GPS devices and roadside units. These probe data of trucks are to be shared with logistics companies and applied for making more efficient truck management and also safer driving. Truck load matching system, which is operated by Japan Trucking Association, gives opportunities to match the truck space of freight carriers and demands of carrying goods by shippers via internet. It can contribute to reduce the empty truck movements and result in alleviating traffic congestion and improving the environment. Next, let us discuss economic policy measures, which include charging schemes and subsidies by public authorities. Road pricing and environmental tax impose charges on freight vehicles entering city center for decreasing the level of traffic congestion. Policy of increasing truck parking fee in the city center is also effective to reduce the number of trucks. We should have careful examination about the scope of applying area, types of trucks, and pricing level before implementing them. Subsidies are often given by municipalities to provide companies for promoting intermodal facilities, joint delivery systems, and low-emission vehicles. Congestion charging in London gives good practice of road pricing to reduce the number of vehicles in city center. Passenger cars, as well as freight vehicles coming into city center, are charged. Joint delivery systems with urban consolidation centers, UCC, are typical city logistics policy measures. Subsidies for starting projects are often given by municipalities, but in many cases, the project failed after quitting subsidies in 3 to 5 years. However, here you can find good practice of joint delivery systems with UCC in Motomachi, Yokohama, Japan. This initiative started in 2004 and has been well operated until now after subsidies by municipalities stopped because they have their own business of car parks and others for supporting the joint delivery systems. About 20 freight carriers take part in joint delivery systems, and they drop off goods at the UCC, and the UCC operator deliver goods to shops and homes from UCC using CNG trucks. The role of municipality in Motomachi is not giving financial support, but providing legal advice of operating joint delivery systems and preparing a loading and unloading space for delivering commodities to customers. Leadership of the project is taken by Motomachi Shopping Street Association. Let's look at regulatory policy measures. One is regulation, including truck ban, access control of trucks, designated truck route, time windows, and low emission zone. Other measures are standardization of containers, IC tags, and onboard units of ITS associated with urban goods distribution. Before implementing regulation measures, we need to carefully examine the impacts of these measures, since we often encounter unexpected side effects. For example, truck ban against large trucks in urban area may generate more number of small trucks and result in higher congestion and more greenhouse gas emissions. Here you can find access control of freight vehicles in Bordeaux, France. Trucks whose gross weight is over 7.5 tons are not allowed to run the major streets in urban area for a certain time period. Time windows are set for those trucks in city center in the morning time. Bordeaux Metropole, which is a multi-jurisdictional agency, has discussed and proposed these measures, and City of Bordeaux has implemented and operated it. On-street loading and unloading spaces for trucks are provided in Bordeaux together with access control of trucks. The parking management of trucks is essential for better services of goods delivery to customers and reduce illegal parking. Designated track routes are set in Chicago, United States, depending on the size and weight class of tracks. The track route policy measures are effective to promote efficient and environmentally friendly urban freight transport. Chicago Metropolitan Area Planning, which is a multi-jurisdictional agency, developed comprehensive transport plan, which include load freight transport management and designated track routes.